Hey guys, we're repeating 3-axis because we've got Danny from engineering that also wants to hop on board. Danny would be using SolidWorks or some other solid modeler that's parametric, so the Rhino interface would be quite alien to him. But it can't hurt you guys to see how it's done in other software as well. And then I'd also like to say that probably this is not a bad idea for you, for those of you thinking getting into it. We're looking at Fusion 360. It has a free version which you can get from this link over here. Just Google Fusion 360 for personal use. It has some limitations. It can only go up to 3-axis. So for the purposes of this video, perfect. On the paid version, it does support multi-axis 4 and 5-axis machining. Alright, so we're going to build this piece or something quite similar to it. I'm going to run you through the simulation quickly. For the guys who are doing Rhino, this is going to look completely alien to you. It has a parametric side tree and a parametric cross tree, which is something that Rhino doesn't do. Okay, but it's a super powerful tool, and you'll see when we're drawing why I say that. Okay, so there's a couple of different operations. It's running through them. There's pocketing, there's contouring, there's chamfering, everything we did in previous previous videos. So I'm just going to do this, and you can kind of see what the outcome is that we're hoping for. We want to cut a little tablet. We want to face it. We want to cut the outside, leave some tabs. We want to use a chamfer mill to get the edge. We're going to pocket on the inside, and then we're going to pocket out the wording. Alright, so I'll go through that in a new sketch for you, but I just want to show you the power of working in an actual parametric program. So I've turned off the model so we can't see it. The model is in there. I'm currently in its manufacture mode. You'll understand that more in a minute. Let's go back to its design mode. Now you can see that if you start looking at your actual component, when you look at the component, everything is selectable as individual pieces. But more than that, when the component is built, it's built in a parametric tree. So you can see all the different extrusions I did. I built a sketch, and then I extruded the sketch, and then I did another little sketch, and I extruded the sketch there. From the very original sketches, you can kind of, so that's all just the little curves that we did. From all the original sketches, I can change any of these lines, any of the parameters, and the whole drawing will update, including all the CNC work we did afterwards. Okay. I'm going to start from scratch. Danny, welcome to the tutorials. I think you'll find this interface not too far from what you're used to in SolidWorks. It's basically just a very, very dumbed down version of SolidWorks. Alright, so we're going to start a new file. We've got a blank screen. So for everyone else, your right mouse button rotates your screen. You can jump over there and get a top view, side view, whatever you need. Your middle mouse button pans, and your left mouse button selects. Okay. So the first thing you want to do with this is you want to start with a drawing. It's a little bit different to the way Rhino works. The drawing and the model is always visible at the same time. It doesn't work like that in Fusion, nor does it work like that in most solid modelers. Alright. So you start out, you're in the design tab. There's a variety of tabs on the left hand side, from designing, generative design, which is not available in the free version, rendering, animation, water flow simulation, airflow simulation, manufacturing, which is our CNC, and then a couple of drawing tools from external designs. As you can see, I do have the full version, so I've done some 5-axis stuff, but I'm just demoing it in the demo version, so everybody's interface looks the same. So we want to be starting out in the design section, and you'll have nothing on your screen. You've got to start with something, so you start at a sketch. So there's a couple of ways to get to this. You can just go up to there and you can click on create sketch, but at any point anywhere in the program, if you're looking for, I guess what you'd call a Rhino command line, just hit the S key and it brings up your shortcuts. You can start typing any command. So I want to do a sketch, create a sketch. Okay. The sketch wants to know what plane you want to be working on. So you want to draw a sketch on the left hand side, right hand side, looking down. I want to be working on the looking down face, so I kind of go like that, and okay, so I can see there I'm looking at the top, so that's the top one, and I'm going to click top. It's going to straighten up the drawing for me, and it's going to replace the tools on the top with the sketching tools. So we're going to start with a very, very simple very simple sketch. Hey man, bugging myself up a little bit there. Alright, we're going to just be making a little block, maybe like 50 by 50 or 40 by 40, a little inset in it and some text. So the first thing is we need a square. So up at the top I'm going to grab a 2-point rectangle. I'm just going to start dragging. Doesn't matter where I click, I'm just going to start moving out, and you can see that one of the 2 dimensions is already editable for me. So I'm going to go 40 by 40 for this example. I'm going to type 40, hit enter. The other side is not 40, but we're going to fix that now. So we're going to highlight that, and we're going to put a dimension on it, and I want to make that also 40. Now you could have dragged that out manually, but by having the dimensions on screen allows you to quickly adapt the actual size. So this is the first difference between the Rhino guys and SolidWorks guys. SolidWorks, this is default. So at any point you wanted to change this dimension, you just double click it and say that, oh, I don't want it 40 anymore, I want it 45, and the drawing will adapt. Okay, so I'm going to put it back on 40 for now. The next thing we want to do is I want to start just radius this edge a little bit, because we're trying to maybe emulate a tablet. So I'm going to put some radiuses in it. Okay, I'm going to the modify tools, and I'm going to put a fillet in there, and I click there, and I'm going to click there. I want to put a fillet between those 2 curves, and I want that fillet to be, I don't know, 6 millimeters. Alright, and then I'm going to click here and here. It's going to keep the last measurement, and then I'm going to click here and here, and I'm going to click here, and I'm going to click here. Alright, I'm going to press enter and finish the fillet tool. Now I can change the dimensions of this thing to 35 by 35, and it will keep the same radius fillet. Second big difference between Rhino and solid modelers. Okay, it's parametric, so it retains the drawing. So if I come in here and I made this 30, you'll see that the same radius fillet was kept. Okay, this can be very, very handy for those of you that do more engineering kind of tasks, where your base drawing, so the extrusion that you saw previously, if I'd come back into this drawing and changed the fillet, the entire drawing would have updated, because the entire drawing is based on this first curve. So for now we've got the base that we want. I'm going to finish the sketch for now, and we're good to go. We're ready to start the next part of this job. So we're back in the design tab. We can now start creating solids from this. I'm going to just select that surface. I'm going to click the extrude, and I'm going to extrude this directly upwards 5 millimeters. Okay, now see what happened in the bottom here. It's saying you started with that sketch, then you did this extrude, and everything I do, it's going to add stuff to it. If I want to change anything, any point later on, oh, I don't want it 5 millimeters high, I want it 6 millimeters high, I come in and click that thing and just type 6 and update the entire drawing. Okay, everything that happened after this point would update with it. So that's parametric modeling. Alright, kind of get used to it, because probably it's the way that most CAD is going. Okay, so we've got the outside line. We now want to just come in a little bit, because we want to leave a little flat area over there for the chamfer, and we want to do a little inset. So I want to make a new drawing on top of this plane. So I'm going to highlight that plane, and I'm going to click on create a new sketch. I don't have to pick a plane this time, because I already had one. Alright. So within this plane I want to do an offset. I want this outside curve, and I want to bring it in a little bit. So I'm going to click the offset tool over there. There's a whole bunch of them through here, but I particularly want the offset tool. It's going to ask me what did I want to offset. So it's already by default in the select mode. I want to offset that curve. I want to bring it inwards by, let's say, 5 millimeters, 4.5 millimeters. So minus 4.5, because I'm coming inwards. And I'm okay with that. Alright, so I'm going to press enter. At this point I don't want to sketch anything else on here. I'm going to add some curves a little bit afterwards. So I'm going to finish this sketch for now. Okay. Now I can bring that radius in, because it is still a radius. If I didn't like that amount of curvature and I wanted more curvature, I'd just go back in, edit the sketch, and change the radius there. Okay. For now I'm going to keep it on this, and we're going to start working. So I want to bring this surface down by 1 millimeter. So I'm going to grab that surface, I'm going to extrude it. I want to go in a negative direction by 1 millimeter. And presto, I've now got a little inset area over there. Now we want to put a little bit of text on here, so I'm going to grab that, and I'm going to create a new sketch on top of it. And I'm going to add some text. Where is text? There we go. Oops, let me just move this out here. It's going to ask me more or less where I want the text. We'll move it around later to suit. So I'm just going to click over there. We've got a selection of fonts. We can type anything we want. I'm just going to do the same thing I did before. I'm just going to type the word CNC. You can change your size of the text, and or you can drag it out bigger and smaller later. For now, you just want to get it out there. Make sure you've got more or less the right font. Okay, so I'm just going to click OK for now. And I'm going to move that to about there somewhere. Looks more or less centered. There are more professional ways to do this, of course. And we're going to click on Finish Sketch. So now we can do the next part of doing an inset, because we're back in the drawing mode. So I'm going to grab just that little bit, and we're going to do an extrude. And again, I'm going to go minus 0.5. I just want to go down 0.5 millimeter. And so we've done the little offset inside there. And you'll notice that all the way along, it changed for me. So for some reason, we decided that that 1 millimeter wasn't enough down. That was this extrusion here. So we double click it again, and we say I want minus 1.5. And you see that it's increased that, and I redid all the work to change all the booleans. Everything is done again. And similarly, I can come back to this one and say that I no longer want it 6 millimeters high, I only want it 4 millimeters high. And the whole drawing will adapt. Super, super, super powerful. All right. Our CAD drawers, I've been trying to teach them how to do this, and they are struggling a little bit. It's not intuitive for organic designers. All right, so now we can get to the point we want to start doing some CNC on this, okay? So I've pre-made some cutters for this video. For Ben and everyone else that's seen making cutters, it's the same thing. How long is it? How many flutes has it got? What size is it? I may make one just to get this a little easier. So if we're happy that this design is now finished, we can move away from the design tab and go into the manufacturing tab. Okay. You'll notice along the top that a lot of the more advanced functions like automatic hole detection for drilling, multi-axis, modifying your stuff is not available, but the majority of the things you're ever going to use in 3-axis on a machine are available for you. Okay. So the first thing we want to do is we want to face this off. We may have put a bit of stock onto the machine. I think I made this 4 millimeters. So the stocks may be 4.2 or 4.3 mil. Maybe it's not even. Maybe it's 4.5 on this side and 4.1 on this side. We just want to face that surface area, get it nice and clean to start the machining. Facing is going to try to stay within this curve. So what I might do is go back out of manufacturing into design and just give myself a slightly wider curve over there. I'm going to look for my sketches, and my third sketch was this one, and my second sketch was that one. So I'm going to work on the sketch again, and I'm going to grab, and I'm going to do an offset. I'm going to offset that curve outwards, just another millimeter, just to be safe. Now I'm going to make it 2 millimeters. Okay. And I'm going to finish that sketch, just so that I've got a little extra area to work with just for the finishing. So back into the manufacture tab, and we're going to use just 2D tools for now. Actually, most of this is going to be 2D tools. We won't really touch 3D tools in this tutorial. And I want to do facing. I want to clean the face of a piece of metal. So I'm going to click the facing tool, and now you start seeing the first cam tools come up. All right. We're going to select a tool. In the case of the little machine we've got at the moment, we've only got 3.17 mil end mills. I've pre-prepared a few of them. There's one over here. Otherwise, you can look through your standard tools along the side here. So you've got sample profile tools, sample tools in metric. You can copy and paste a tool and change its parameters. So for example, if we didn't have a 3.17, you could grab that guy, you can copy it, go into your own library over here, paste it in, and edit and play around a little bit. So it's really easy to make tools inside here. For now, I've got one made up. I've predefined it. Okay, and we're going to start cutting. So what have I got here? 317 flat end mill, 45 degree chamfer, and you. All right, so let's start with you. Let's select it. So we've got our tool selected. Okay, cutting feed rates are pretty much okay. Very good. If you select, because I made this tool myself, I don't have a lot of the materials available, so let me just show you that again. If I select it from a ready-made, let's filter by diameters, and let's go down to 3 mil. So there's a a ready-made by them 3mm flat end mill, and you can see that it's got a whole lot of feeds and speeds associated to already for cutting titaniums, plastics, aluminium. Okay, I might just grab that one for now. 3mm aluminium finishing, select it, and then you'll see that the feeds and speeds here have changed for aluminium. Okay, for gold it would have to be different again. For different metals it's a little different. Okay, so we're done with the first menu. We've seen our feeds and speeds are good. For this particular cut, I don't want the flood coolant enabled, so I'm going to disable it. That's just a big pipe that pumps water over your cut to keep the cutter cool. On hard steels you do need it on, but on most of the stuff we work on, probably not. What are we going to cut? I'm going to say that I want to cut everything inside here. Alright, just to give myself a little bit extra space. Our clearance heights, now Ben and everyone has seen this before. This is a little bit critical, guys, because if you make these too close, you could bump into stuff, especially if your stock material is not very flat. Okay, but this is a little bit insanely far away, and in some cuts where the cutter has to move up and down a lot, what this clearance plane means is it's going to actually move up 15mm at a slow speed, come all the way over, and then come down again, and all those up down movements can really slow down a path. So if you know that your stock is like this and it's pretty much already flat, you can grab these. They're a little bit more intuitive than they are in Rhino, and you can just move it down till they visually look about right. Okay, I like to go about 1mm intervals between my various clearances. Okay, so you can see over there it's saying that the bottom of this cut is 1mm under the stock, the clearance plane is 1mm above it, and the top is on the stock level up the top. Alright, so we've pretty much set our clearances. And again, the clearance is where the cutter is going to move to when it has to move rapidly in between cuts. You want to make sure that if you've got warp geometry or stuff that you're planing, be sure to give yourself enough clearance. Alright. Your tolerance for a flat cut is not super important, so I'm not going to play with it now. We'll look at this a little bit later. Alright. Now if you had a lot of stock to get through to get to your finish height, you may want to do multiple depths. Alright. So common logic is you should never go deeper than half the width of a tool. In this case the tool is 3.17, so 1.565mm. You wouldn't go deeper than that, so if you had 3 or 4mm to cut through, you'd do it in little steps. Okay, I'll show you what that looks like. You can just say that per step I don't want to cut more than 1mm. Alright, in this case we're right on the ground, so I'm going to turn it off. Stock to leave, we want to leave no stock, we want to cut right to the bone. Had you put an amount in there, it will come down, do the facing, and leave a little bit of material over the top, because you may have wanted to run another facing with a smaller tool to leave a finer finish. In this case I'm good with that, so we're just going to go. There are a few advanced options at the back over here about linking between paths. For now you don't need to worry about that. Alright, so all you got to do now is just click OK. Whoop, and my feeds and speeds tripped me up. Give me a second. Sorry, my clearances tripped me up. So my clearance, feed, okay, what error did it give me? Retract height must be above the feed height. Oops, okay, so my bad. So where's my retract height? Oh, my feed height, there we go. So my retract height, this guy here. Okay, good. Alright, so okay. And you can see that it generated a path. It pre-simulates it for you. I like to just run it manually anyway. Alright. If you don't want to see the model in the background, you can turn it off with a little eyeball guy, or turn it back on. Doesn't really matter. To simulate it, you can simulate all your paths at once by right-clicking Setup and click Simulate. In this case, there is only one path, so it doesn't really matter. It's not too important. I like to leave this on Standard. It gives you a very rough look, but it cuts a lot faster. And then after I'm finished with it, I like to move it to Fast 3-axis and set it to Extreme Quality so I can see what the quality of the cut's going to be. For now, don't worry about it. You can just leave that. It's just a simulation. Okay. And you can click the play button to start the simulation. This is the speed of the simulation, how fast you're going to simulate it or not. Start off slowly and you can always speed it up. Okay, so it shows you the cutter's going to go in there. Alright, the stock that it makes by default is roughly the size of the largest solid part it can find. But in the real world, your stock might have been significantly larger. Alright, so always give yourself a little bit of clearance. I'm going to speed that up a tad just to get through this. And we can see that we're pretty much getting what we wanted. It cut down to the bone and you've got a nice flat surface on it. Okay. Once that's done, we can move on to the next step. I like to cut from the largest cutter towards the smallest cutter, or the largest load-bearing cut to the lowest load-bearing cut. So the one that has the most impact on moving the part, that will be this one. The next one would be probably the pocketing to clear out this inside. The next cut would be filling the outside, and then finally we're changing to a smaller cutter to cut the curves on the inside. Alright, so we can exit sim now because we're happy with what we got there, and we're going to move on to the next part that we want to cut out. So we want to do a pocketing inside here. So I'm just going to go into my models. I'm going to turn off that last sketch that I made. I don't want to really see the sketch, and it was in my way. I couldn't access this. So if a sketch is in your way and you can't see over here, that particular sketch is highlighted, so I can't get to the parts underneath. Just go in and turn it off, and now you can get to all your parts. Alright, so now we want to do another pocketing, because this is now one big flat block of metal. We want to cut out this hollow. Alright, so again we're going to go to 2D. Now again we're going to go to 2D pocket. I say again because I've done it before. My apologies, we haven't done it before in this video. So we're going to do a pocketing for the first time. You do need to select a tool. By default, the last tool you had is pre-selected, which in this case is fine, but had you meant to use a different tool, go change your tool out. Coolant is disabled and feeds and speeds are still set. Okay, so aluminium finishing. Now, where do we want to cut a pocket? So far nothing is selected. I'm going to say that I want something, and I want to cut everything inside of that bottom curve there. Okay. Nothing else you need to change over there. Heights, this tripped me up last time, so let me not bugger it up again. So you down a bit, and you down a bit, and then you down a bit, and then hopefully I don't get in trouble. Okay. The passes, again you can see that the top here was at the stock previously, so that the top we'd be cutting 1 millimeter of nothing, because our previous facing operation already removed that first millimeter. So in this case the top, I think we can bring it down so that it doesn't have to be at the top of the stock, it needs to be at the top of the model. Okay, otherwise we're just wasting time cutting stuff. Then let's look at our passes. We're using a fairly big 317mm, but that is 1.5 deep, so hypothetically that's what it can cut in one pass. You may want it to have multiple depths. If you're cutting something very sticky like platinum or so, you may want to do this in multiple steps irrespective, but let's start again from the top. Okay, so that tolerance thing we spoke about before, you can kind of see if you get in here. Oh, there's a thing popping up that won't be in the video. Goodness me, I'll explain it when I meet you guys. It's how close the cutter is going to follow that curvature. Alright, because at a zoom, if you zoom in a lot, you can see that this model, oops, you saw it just disappear there. So let me zoom out, and you may see it again. You see how it looks kind of jagged? Okay, because at that view the tolerance was very thin. At this view it increased the tolerance a little bit, so I don't see the triangles. Okay, you see it did it again. Alright, so what it just means is when the cutter comes around this corner, it's going to make positions along this corner for the cutter to move on. And if those positions are too far apart, the corner might end up looking like a bunch of flat sections instead of a nice curvature. So this is the distance between the stops of the cutter as it makes its way around that corner. The tighter this is, the more like an actual arc that's going to look. Alright, so I like to, when I'm doing cutting, I like to bring that down to 1 micron. Okay, the sideways compensation you can just leave alone. no issue for that. I will explain when we're in front of the mill what the difference is between climb milling and conventional milling. Okay, climb milling, just be aware, it gives you a much better finish. For now, that's all you need to know. All right. In this case, it's going to do a whole big cut, and if you do tick finishing pass, it's going to come in one more time and just do one nice clean cut around the edge. So I do want to use a finishing pass on this, and I'm good with that, and I'm good with that. All right. I'm going to show you what multiple depths does. In this instance, I'm going to say that I'm going down 1.5 mil, but I only want to go down 0.5 mil at a time. All right, so I would put in here 0.5. It's going to waste a lot of machining time in this instance, but in something like tantalum or gold, you may be forced to use smaller step downs, basically forcing the cutter down. How much can the cutter cut at any one time? Nothing else there we need to change, and I think pretty much we're okay. That's fine, yeah, I can ignore that. Alright, so we're going to simulate that. So far, let's simulate the whole thing again. And we can see from scratch what the machine is doing. I may just turn off that model so it doesn't show up underneath. Let's speed up this first boring bit. So it's going to come down that first 0.5 mil, then down another 0.5 mil. Okay, well, I must have only had it down 1 mil then. It seems to have cut the whole lot at one go. Alright, so we've got a perfect flat. We've got the pocket. Now we want to cut out the outside of this with a couple of tabs and then start doing the engraving on the inside. So for now, I'm pretty much good with all of that. I can close out this. The machine didn't do anything stupid. I don't see anything flying around that I don't like. I'm going to turn my model back on. Now we want to start cutting out, we want to start cutting out this outside. Okay, again, we're using the big tool. I want to go around this outside and cut it out of the stock. So that's again going to be in 2D, and I think this time we're looking for a profiling cut. Have I got one? 2D contour. Okay, so some software calls it a profile cut. In the software they call it a 2D contour. Alright, so I've still got the right tool. I'm good with that. I don't need flood coolant. We do want to cut in aluminium. Alright, my geometry wants to know what am I cutting. Okay, so we're going to select this bottom curve over here because I want to cut all the way around this to that bottom curve. Nothing else needs to be changed there. You know what, I'm not going to bother with the heights for now. And then what is my tolerance? Again, in this case, this is actually going to be the outside of this part. It needs to be nice and clean, and we want those corners to be really round, so we're going to increase that tolerance a little bit. Pretty much the same as we saw in all the other stuff that we've been cutting, so nothing really to talk about there. In this instance, we are going to need multiple depths because this is going down 4 millimeters. If you try to stick a 3 millimeter end mill all the way through this metal to 4 mil deep, 100% for sure you're going to break a cutter. So in this case, I'm just going to say that I want 1 mil passes on the way down. So it should generate 4 of them on the way down. Now I don't want to leave any stock. No smoothing, okay. And we can just click OK. Alright, and this roughness over here, I'll show you how to make that look better in a second. So let's just re-simulate that, and that's what I think I was saying a little bit earlier. If I'm going to, if I want it nice and clean, I run the simulation, do it nice and fast, and then come in afterwards and change your mode to there and extreme. And then you can see that you've got a nice clean surface. Alright, well, cleanish looking surface. So far that's looking pretty good. I'm going to resimulate the entire thing from scratch just so I've got it going. Oh, I think I must have left some skin here because I can see something's not good there. So let's go edit our second part. Let's get out of here. Let's look at my 2D pocket. Did I ask it to leave some skin? Let's have a look. Geometry, heights, cut. Did I ask it to? Oh, see, I don't need to leave any stock. I want no stock in this case. That's why it wasn't coming quite up to that line. So let's regenerate that whole lot. Oops, okay, we can click on OK. And let's regenerate everything inside there. Okay, and then resimulate everything inside there. I'm going to do it quickly. quickly so we can just get through it. Alright, so we've got most of everything we need. Now we want to put a nice chamfer on the edge here, so we're going to use a chamfer mill. A chamfer mill is like a flat mill, except that it comes down at like 60 degrees or 45 degrees. It has a very sharp angle on the edge, and you can use it to put a chamfer on the edge of stuff. So far we're happy with what we got, so I'm going to jump out of this. Then we're going to add a new operation, 2D threading, facing, tracing, somewhere should, oh there we go, 2D chamfer. Alright, so we're going to run a 2D chamfering. We're going to need a different tool now. I think I built one over here. Did I? 45 degree chamfer tool. Alright. And you can see that it's just the same as a normal tool, except that it comes in very sharp, and we're going to use that edge to cut a kind of an angle. Alright. I don't need any flood coolant. On the machine we have in the workshop, it doesn't matter whether you turn this on or off, it doesn't have coolant anyway. But do look after it if you're using a machine that actually does have flood coolant and you don't feel like washing the floor. Alright, so what geometry do you want to chamfer? I'm going to select this contour on the outside here. I want to put a chamfer on this one. Alright, so we're good over there. I'm going to leave those clearances alone. Alright, so again, it is a curvature, so I want a very tight tolerance inside there. The chamfer tool is 3.17, so let's make it exactly half, well, close to half the width of the tool. I want a 1.5mm chamfer. That just basically means it's going to come in 1.5mm with the chamfer tool. I don't want any offsets. I want it exact, and I want an exact chamfer. I don't want it kind of halfway down, kind of halfway not down, and we're just going to click OK. Alright, so we're going to turn off the model to see that, and you can see that it's gone in as kind of cut a chamfer. So let's simulate that again. Simulate the entire operation. Click play. Sorry, this is boring. I'm just going to jam through it fast. And then we're going to change it over to that. Oopsie. Yeah, and we can kind of see that we've got a nice smooth finish everywhere that we need. The chamfer tool has come in. It's put a nice little 45 degree angle on the outside. So anything left to do now is cut out that text on the inside. So let's close this guy down. Turn on our model again. And I want to be working with those faces down the bottom. I want to do another pocketing. This time I want to do it with a much smaller cutter. So I'm going to go 2D pocket again. I'm going to select a much smaller tool this time. Have I got one through here anywhere? Pretty sure I saw one standard 1mm cutter in here somewhere. So let's have a look in our library. Let's take you. And what tool number are you? You're tool number 1. Let's take you and copy you and paste you, and let's edit the pasted tool. Alright, and we're going to call this 1mm flat end mill. It is a flat end mill. It does have 2 flutes. It is carbide, and it's only going to be 1mm for us in this instance. 1mm shaft diameter is fine. I'm good with all the rest of that. Okay, again, so Ben and everyone else have already done a few lessons with me. All these parameters are available on the tool that you buy, generally speaking. Alright, so I'm just going to accept that for now. And we've got to hope that a 1mm tool is actually going to fit in these grooves. Pretty sure it will, but we'll find out in a minute. If it doesn't, you're going to have to find a smaller tool. Okay, so we've got our tool selected. I don't want that. We're good with the feeds and speeds. So what do we want to pocket in this case? So let's select them. And this is the beauty of solid modelers. You just go in and go, I want to cut that face, and I want to cut that face, and I want to cut that face. Alright. Apologies. We've got our, I'm not going to bug around with those again. This, again, very tight. Okay. I do want to climb mill, so nothing to be changed over here. We're good over there. Maximum step over is I want 0.1mm, 1/10 of the tool. Give me a nice fine cut. I don't want to leave any stock at all. Is that more than half? It was 1mm deep, so yes, I do want multiple depths, and I want them at 0.5mm each, or 0.25 each. Alright, we don't want to leave any stock, and I think pretty much we're Ooh, let's go have a look at that again, because I think it's going to be wasting a lot of time. Where's my top currently? Yep, because my top is still set to stock. Okay, so I'm going to take that top. What it's going to do is at a half mil step down, it's going to start those half mils from this blue line. So it's going to waste a lot of time trying to make its way down to there. So I'm just going to take this and I'm going to drag it down until it's just above that surface. Okay, so we're good there. And then we can click OK. Something doesn't look good there. Something certainly doesn't look good there. Cut in the end. I think a 1mm tool may be a little bit too small to get into some of the lettering. Is that right? Anyway, let's simulate it and have a look. We're going to have to simulate the whole thing. But again, I'll do it quickly. So I wonder why it couldn't get into there. So I think maybe that cutter is a little bit too fat to get past these curvatures. So we may have to go in and edit that to be a smaller cutter and see if we have better luck. Of course, in the real world, you'd be going in your workshop and making sure you actually have a smaller cutter. Okay? Or you'd be changing your drawing to be a little bit thicker, a little bit bigger. So let's go that way around because I've been bragging about how good parametrics is. So let's just cancel this out of here. And let's go back into our drawing mode. And where was my last sketch with the text? That was the one. So let's edit it. Oops. And let's make it 9mm. Still going to fit. Let's have a look. Yeah, I think it's okay. And then see if I think I might even want to make it a little bit bigger than that. Want to get away with 11, maybe. No, I think 10 might be enough. Alright, so I'm going to click OK. And because we made that text a little bit bigger and we repositioned it here, we click Finish Sketch and we come back in the drawing. The whole drawing is updated. When you go back into Manufacture, the little red dots are saying that this has to be regenerated. Alright, so you just right click, click Generate, and all the parts will be regenerated. And then we have a look once it gets to the bottom one. Yep, the cutter got in this time. Okay, so we could have gone with a smaller cutter, or we just decided to make that feature a little bit bigger for CNC. So I'm going to simulate the whole thing again from scratch because that's the part now complete. Okay, we're pretty much where we started in the beginning of the video. Alright, so let's go again. Right click, let's simulate the whole lot. I'm going to turn the simulator a little bit slower this time. I'm going to put it on standard. We're good to go. Yep, let's go. And we press play. So the really boring bit, I'll speed up a bit, just that part. Alright, so the pocketing. So the first one flattened off to this surface that we needed here. I'm going to turn off the model. The second one is going down, pocketing to get down to the little inset that we made. In 1, 2, 3 steps because we're no longer keeping skin. Alright. Speed that up a little bit. Oopsie. And now the outside cut is cut. Oh, I forgot to leave tabs in here. Goodness me. My apologies. Alright, because that will go flying all over the workshop. I know that Ben's sitting there laughing, going, haha. Alright, so that was the outside contouring. There is a tab for it. So we're going to just edit that. And somewhere along here is a thing that asks me for tabs. Roughing passes, multiple depths, roughing, linking, leads, ramp, positions, passes, roughing passes, mold stock to leaf, feed optimization. I might have used the wrong geometry. Tabs, there it is. Alright, so we do want to leave some tabs around this. You can see by default it's suggesting those 4 tabs around there. Most of the time it'll suggest good defaults. Okay. So what the tab is for is when the cutter comes down, imagining that this was to the bone, if the cutter finished the last paths and cut this piece completely free, you've got to cut us at 12,000 RPM and you've got a loose piece next to it and it wants to jiggle around. It's going to get cut between the material that it's in and the cutter trying to force it out, and most likely you're going to damage the part and you're going to break the cutter and maybe even bend the spindle. So I'm going to click OK, and we're going to regenerate that, and you'll see the final pass now is leaving those little tabs. Okay, so I kill a lot of time here, so I'm going to resimulate again from scratch so we can just watch that. Apologies, guys. Let's speed that up a lot. Okay, so it's coming in. Now that's, remember I said to you, it can be very wasteful if you don't set your heights properly. So it's coming in from this insane height, and if I just change my retraction height a little higher, that wouldn't have wasted all that time doing that. However, it can't hurt to be a little bit more careful than less careful. Alright, so let's get through the last of that machining. Okay, and then if we change that over to fast 3-axis and extreme, we can get a better look at what I anticipated finish would be. So I think that's pretty good. Okay guys, so let's turn off the model so we can see the entire part. Yep. Okay, so that's using just 2D tools. So this is like the start we did in Rhino to create a 3D item. We haven't even touched the 3D cutting tools yet. Okay, so using just a couple of curves, you got pretty far. And then again, like I said, because this is because the entire thing is parametric, any of these changes you wanted to make, you can jump all the way back through your model line. So this original one was extruded to 4, and I don't know, Andrew said, oh, let's make something a little bit thicker for the customer. Just press 6, the entire drawing updates. All right, you just go to design, you go back to manufacture, regenerate, hey presto, you're done. Quite a dramatic design change, and you didn't have to do all that work, draw it all again, regenerate all the paths. You just click the little thing down there and you change the number. Very handy. Okay guys, that's it for me. Cheers.